welcome you back to Physics 101 class. Today we'll be considering study session 5, and the topic we'll be looking at is elastic properties of material. So by the end of this study session, you should be able to explain what elasticity is in a material. You should be able to state Hooke's law and apply it to determine some variables in a material. You should be able to discuss molecular properties of fluid such as viscosity, adhesive force, cohesive force, and all that. So you should be able to discuss them. Now, the first topic we'll be considering is elasticity. What does it mean? Elasticity is a crucial concept that is used to describe how material respond to deformation. Imagine holding a rubber band and you are stretching it. You will notice that immediately after you release it, it will go back to its original shape. However, if you continue to stretch it beyond certain point, it won't return to that original shape. This indicates that there has been a permanent distortion in that material. So when it returns back to its original position, we will say the body has undergone an elastic deformation. But if it does not return back to its original position, we will say it has undergone a plastic deformation. So plastic deformation occurs when a material did not return back to its original position after a load or a force has been applied on it. However, elastic deformation occurs, and after a force has been applied or a load has been applied, the material returns back to its original position. In order to understand this concept very well, that is what will lead us to Hooke's law. Now, what is Hooke's law? Hooke's law is saying that provided that the elastic limit of a material has not been exceeded, it is very important, that condition. He said the load that is applied to the body is directly proportional to the extension that the load is going to produce. Now let us put this law in mathematical terms. Say force applied is directly proportional to the extension. Force applied is directly proportional to the extension x. Alright, now if you are going to write it, you say F is directly proportional to x. Putting it in mathematical form, putting equation in this place, K is going to come in, that is the constant. So when K comes in, you are now going to have F, which is the force applied, equals K multiplied by X, where X is the extension. The K there stands for elastic constant, and it is represented in Newton per meter. I hope you know how we got this unit. You know the force. If you make K the subject of the formula now, K the subject of the formula, you are going to have F over X. F is represented in Newton, while X will be in meter. So that is why we have Newton per meter. So that is the unit for representing the elastic constant. Now we move to the concept of stress and strain. When we say stress and strain is just making us to understand that the Hooke's law is applicable to any material. Now what do I mean when I say is applicable to any material? Let us consider that you have a beam or a material like this, and you apply a force F on it. You know by default, every material has arrangement of molecules somehow. That is what is arranged in materials that make up that material. Now when force is applied, the height of this, let's say this original length is there, let's say it is L. Now when that force is applied, by default the length will change. It will reduce because these particles must have compressed. It has compressed here. So the height will have reduced from this place, from here to this new position. So now what we will say occur here is that there is a change in length, which is delta L. Now if Now the delta L here there that occur, that is the change in the length as a result of the force that was applied. Now what stress is simply saying is that the force that is applied to this material divided by the area of the material. That is what stress is now saying. Now if the elastic limit of this material has not been reached, immediately the force is removed, you will see that the material will return back to its position. Now this concept is very important for us to understand, especially for engineers. That is why they are able to know what load a material can carry without failing. So if you overload a material beyond its capacity, the next thing that will happen is that such material will fail. When it fails, it means it will not be useful for the purpose for which it is made again. So to determine force is going to determine stress is going to be force divided by the area of the material. Now let's go a little bit further. When you want to determine the strain, recall that we said that the length, there is a change in length of the material as I have stated earlier. The strain is simply going to be that the change in length of that material divided by the original length of the material. Change in length of the material divided by the original length of the material. And note, when I say change in length, the change in length is simply going to be the original length minus the new length that just occurred now divided by the original length. So that is what the change in length is. And this strain also is applicable to any material. Let's say in terms, when I say applicable to any material, is in terms of area or in terms of volume. If you are given a material and you are asked to determine the strain in the material and you are given the area or volume of that material, it is very easy. What you just do is change in area. The strain is going to be change in area of that material divided by the actual area. And if it is volume, you just say change in volume of that material divided by the original volume of that material. So the strain is applicable to solid, any material of different size and shapes, provided that you can determine the area or you can determine the volume. Now pay attention to this expression that stress is directly proportional to strain. This formula is in relation to Hooke's law also, is in relation to Hooke's law. You know, when we are stating Hooke's law the other time, we said provided elastic limit is not exceeded, that the force applied is directly proportional to extension that is produced by the force. Same thing is applicable here, that provided the elastic limit of a material is not exceeded, the stress on the material is directly proportional to strain. Stress is directly proportional to strain. So if we are to express this mathematically, recall that when I said you are changing proportion sign to mathematical equation, you are going to introduce equal to and a constant. So when this is introduced, the constant there means Young modulus. It's referred to as Young modulus or elastic modulus. Now, if you are to express Young modulus, it's going to be stress over strain. And if you observe, the formula for Young modulus is Newton per meter square. Why is it Newton per meter square? Now, if you observe the formula of strain, we said change in length over length. Unit of change in length is in meters. Unit of length is also in meter. If you cross it out, you see that there will be no unit. So it has strain has no unit. But for stress, unit of force is what? Is Newton. Unit of area is what? Is meter square. So force over area is going to give us what? Newton per meter square. I hope you are following. So that is the idea and basis behind stress and strain. Now let us consider this picture. This picture is very important for you to understand. Now why is it important? Just pay attention and follow me as I'm explaining it. Now this is the y-axis and this is the x-axis of the graph. Now if you observe that we have the y-axis is the stress axis and the x-axis is the strain axis. Now as the stress of a material is increasing, you will observe that the strain is also increasing. That is why you have a straight line which is proportional. Now what this means is that stress and strain, they are directly related up to point A. Now you will see that the line is coming down at point A and there is Hooke's law inside. What this is just trying to say is that Hooke's law holds up to point A. That is where proportional limit A is, which means at this proportional limit Hooke's law holds, the elastic property of the material has not been exceeded. But immediately we exceed point A, Hooke's law does not hold again. Why is it not holding? Because the elastic property of that material has been exceeded. So at this point, it will not return back to the original position, to the initial position before the application of force or load. Now, but it will still return, but not to the original position up to point B. Now, at point B, the material has entered plastic region. This plastic region, it means that there is permanent deformation in the body. When load is applied to the body and it exceeds elastic limit, there will be permanent deformation on the body. Now the yield point, when load gets to this point, the body will just continue to deform without any addition of load. That means when the load that you have added to the body is so much that it got to this point, even if you don't add any other load, the body will just continue to deform. It will continue to deform. And the ultimate tensile stress, this is the point where the material fails. It will just get to the fracture point and it will fail. Now the next topic we'll be considering is molecular properties of fluid. The first one there out of the property is viscosity. Viscosity is internal friction in a fluid. It is the measure of fluid resistance to flow. In simple terms, it describes how thick or thin a fluid is and it is measured in Poisson, that is Pi, and the unit of viscosity is Newton second per meter square. I want to make an example so that you will understand what viscosity really means. You know, when you have water and you pour it, you can understand how easily it flows. But if you get engine oil or you have honey and you pour it, you will see that they did not flow as quickly as water will flow. Now the material, the property that is at play at that point in time is what we refer to as viscosity. You will see that engine oil is thick, honey is thick, while water has a kind of lighter thickness, which makes it flow easily compared to honey and engine oil. The next property that we'll be discussing is surface tension. Surface tension is defined as the energy needed to increase the surface area of a liquid by a unit of that area. It is as a result of cohesive force between the molecules of the liquid. Now, if you observe that there are some material or there are some fluid that insect can work on them. Now, what make it possible for insect to work on those materials are surface tension. Surface tension deals with the compact arrangement of molecules of that particular liquid. So that is what surface tension is. Liquids that the cohesive force within the molecules of that liquid, if they are well coerced together, the surface tension will increase and make it easier for material to work or for insect to work on such liquid. Now, the other properties that we'll be discussing about is adhesion and cohesion. Adhesive force is the force of attraction between a liquid and a solid surface, just to put it in a simple form, while cohesive force is an intermolecular attractive force between two adjacent portions of a substance. Now, example that was given here is water and mercury. If you put water in a cup, let's say this is a cup and you put water in it like this. If you pour this water out, you pour the water out from the cup, you will observe that at the end of pouring it and you put the cup down, there will be some water that will still remain in that cup or in that bowl. Now, what happen is that there is an adhesive force between the material of the cup and the molecules of the water, which make it stick to the water and it not make it pour, make everything to pour away. Yes, others are flow away, but there is still remnant of that water in the cup. What happen there is that there is adhesive force in the water that make it stick to the cup. The example of mercury here, mercury, when you do the same for mercury, you will observe that nothing will remain inside the mercury because the cohesive force within the mercury is stronger, so it does not allow that adhesive force to hold. So when you pour mercury away from the container, no mercury will still remain inside that container. The container will be empty. There will be nothing inside. Now, I want you to remember this very important information. Viscosity of a material is affected by temperature. Now, when I say is affected by temperature, when you have a fluid, I told you that every material is made up of molecule of that material. If you have a liquid here inside a container like you are seeing on the screen, and you light a burner at the base of that mercury, of that water, excuse me, there is fire at the base of that water, you will discover that the molecule of that material, they begin to gain strength, they begin to gain force, and there will be a commotion, there will be a movement in the particle of the fluid. That is when we say water starts boiling. So when there is movement within the particle of the molecules of the fluid, there will be movement, there will be easy movement. So when you pour such, you discover that it will flow easily. So that is why it is difficult for human being to survive in a temperature that is very cold, because what will happen is that as the body is getting more cold, the blood will not find it easy to flow within the body, which will result into death. So temperature has a greater effect on the viscosity of a material. So it's very important for us to understand that. Now the next properties of fluid that we'll be considering is capillarity. Capillarity, what do we mean by capillarity? Capillarity is just simply a capillary action. Capillary action, it can be simply understood by this concept. Now if you have water inside a cup and you take a piece of paper and you dip it into that water, into that cup of water, you will observe that the water will begin to climb that paper. It will just rise up on that paper. So that is what capillary means. The ability of that water to rise on that paper is capillary action. Now the example that is showing on your screen, you see this is a bowl and they pour water in it. They now drop a tube, a capillary tube. In your case, you can get a straw. Just get a bowl of water, put a straw inside. You will observe that the level of water inside the straw or the tube will be more than the level of the water inside the container. Why is it so? It's because of capillary action. You know, we talk about the adhesive force. That adhesive force will make the molecules in the water to stick to the wall of that material and they begin to rise. So that is what happened. But in the case of mercury, we said there is a much cohesive force between the molecules of mercury. So it will create something like a surface tension on that material. So whenever a tube or a straw penetrates mercury, is going to create a resistance at the top, but if you pull it further, so it's going to create a depression. That is why you are having a lower level of mercury when a straw or a tube is inserted into a bowl of mercury. You will see that the capillary action for the two fluid are different. One increases while the other decreases. So this on this point, I believe you would have seen the importance of Hooke's law in our study, how you can apply it to materials in terms of loading that material when you are designing things, or how you can apply it in your day-to-day activity. So I want to implore you to also go through your lecture notes so that you can understand this concept very, very well. And in the course of time, I will give you enough examples to work with so that you can know how to solve equation that relates to Hooke's law, Young modulus, stress and strain. So on this note, we have come to the end of the class for study session 5. See you next class. Thank you.